computing. I think it's fascinating, honestly, that you can Zoom and then live stream to so many different social media applications. That's just all right. We are live. Hello, everybody. My name is Christine. I am the Communications Coordinator Contractor with the South Dakota Specialty Producers Association. Thank you for joining us today for the Rainwater Collection 101 webinar with our guest, Michelle Avis. This segment has been funded under a Conservation Collaboration Cooperative Agreement between the Natural Resources Conservation Service, NRCS, and the South Dakota Specialty Producers Association, SDSPA, that's us, to promote sustainable agricultural practices and environmental stewardship. Its contents are solely the responsibility of the authors and do not necessarily represent the views of the USDA or the NRCS. All right, so today with us is professional expert Michelle on rainwater collection. Michelle, can you just tell us a little bit about who you are, and then we'll let you lead into the presentation.
Awesome. Can you hear me okay? Because you know what? I just got kicked out. I just got completely booted out and I just scrabbled to get back in and I'm not even sure what happened.
Oh no, I can hear you fine. Can everybody else hear?
Okay. Yeah.
Are we having any?
Thought I just checked.
Wow, well, I'm
All right.
sorry
All that
about that
tech check.
rudeness.
Yeah. Yeah, that's funny. All right. So you know what? I caught the very tail end of your introduction. Did you just invite me to dive straight into my presentation? Is that what you did?
Well, why don't you just kind of tell everybody a little bit about your background, who you are, where you're from, how you kind of got into the industry.
Well, and you know what? I actually have a slide, I think a few slides in, all about that.
Oh,
So if
perfect. Well, then, yeah, we can just dive right
I'm
in.
tempted to share my screen, we had this all set up prior to
We did.
me being
We were on the mark.
ejected. Yeah, but we'll recovery on its way. Okay, so question for you guys. Can you see this front slide? Rainwater 101 for gardens and livestock. Just a thumbs up to know that you can see this. Oh, yay. Fun. Right on. Well, then let's dive right into what you guys are going to learn today. Rainwater is about collection, safety, and storage. So I'm going to talk about what I'm going to talk about is also commonly referred to as active water harvesting. You're going to learn that using rainwater is actually really easy to do safely, how to design what I'm calling a multi-barrier approach to your system, and what the best design practices are. And let me reiterate that I'm not talking about water that has touched the ground. That's stormwater or sometimes passive water harvesting. Everything I talk about in this presentation, and when I say the word rainwater, I'm referring to roof harvested water from a building. And that building could be the roof of a shop or a barn or a greenhouse or even your home. Secondly, in this hour, I'm going to try and cram a lot in. And I hope that I'll give you enough to start thinking about, what are the considerations with respect to incorporating rainwater into your garden or with your livestock. And but there's no way I'm going to be able to get to everything I really want to tell you or all your questions. I do teach us like a 6-week course on rainwater harvesting. So I want you to be aware of some resources that you can find should I whet your appetite, pun intended. And one of those is a comprehensive course on rainwater harvesting, which goes into far more detail, especially if you're looking at drinking water for human consumption. And there's I think, Christine, you can share the link to that probably in the chat or with webinar participants. So yes, there's the comprehensive rainwater harvesting course. And there's actually a free course up on YouTube. It's a little bit older, but the content is still excellent. And I'll get Christine to share the link to both of those. So with that, who am I and why do I know anything about rainwater harvesting? So my background is in engineering. I'm also a permaculture designer, co-founded Verge Permaculture, and also Fifth World is where we do all our consulting. I'm also the co-author of 2 books. One of them is Essential Rainwater Harvesting. Another one is Building Your Permaculture Property. And when I started I always had a keen interest in rainwater. And when I really started to research the state of the science, I came across this gentleman, Peter Coombs, and that's why he's on the slide, even though he's not here today. He's an Australian scientist. He's been doing independent research on rainwater harvesting for 2 decades. And what that means is that he's been studying rainwater without not funded from special interest groups, like very much driven by the science and the interest in rainwater harvesting. So his stuff, bar none, is some of the best research out there. And I struck up a collaboration with Peter about 5 or 6 years ago, and we've been co-teaching courses on rainwater since. So both of those resources I gave you on the previous slide are both Peter and I teaching about rainwater. Let's dive into some facts. This is where I'm going to start. And we're going to cover some key things you should have a basic understanding of. So fact number one, rainwater harvesting is an ancient practice that evolved over thousands of years in most cultures. Early Egyptian, Indian, Korean, Chinese, and Roman settlements collected and stored rainwater to sustain human settlements, animals, and agriculture. Fact number two, these civilizations and many others learned to harvest and store rainfall from different surfaces and to manage catchment systems to protect human health. Rainwater harvesting succeeded in drought-prone regions for millennia, and time-tested practices were developed. So this is not some new technology or some new thing. People have been doing this for many, many years. Fact number three, modern day regulation for rainwater harvesting systems is really focused on what I'm saying, mains or municipal water industry end of line treatment. So that means like centralized water supply. It's focused on products and disinfection. However, unfortunately, assumptions that are used in centralized water supply are often incorrectly applied to rainwater harvesting systems, and it produces irrelevant solutions, irrelevant products, irrelevant thinking, and unfortunately, this rainwater harvesting is plagued with irrelevant advice. And because of that, we end up with so much confusion around rainwater. So here I've just shared a screenshot of some, very typical comments about rainwater harvesting. Whenever we post a course or a webinar, this is the kind of comments we very often see from people, right? Just pause for a minute and you can read those. I don't need to read them for you. And maybe you've even thought some of these things yourself. I know I once did before I started working with Peter. I was really concerned about rainwater. Here's another, just a quick screenshot of what happens if you just put into Google, is rainwater safe or is rainwater safe to drink? Let me start by telling you this. The concern over the safety of rainwater is completely misinformed and unfortunately exaggerated. And I believe that this concern is driven by water monopolies that have a huge conflict of interest. Here's what is really important to know. There is a rainwater quality and health paradox. So even though you will find a million things, statements, and even studies, one-off studies on the internet or elsewhere that claim that rainwater is dangerous, know this fact. Large-scale epidemiology studies have been performed. So that's where, health scientists compare large populations of rainwater drinkers, humans drinking rainwater, and they compare their health to similar populations of people drinking other water sources, typically, city water supply or municipal water supply. One particular study in Australia looked at over 3 million rainwater users. And the studies have consistently shown similar or better, actually better health outcomes for people using rainwater. And these rainwater users did not have some sort of a black box treatment, such as chlorination or UV disinfection at the end of their rainwater system, which is what is typically recommended. So stop and think about that. Because if rainwater is so dangerous, where are all the sick people? In fact, it could almost be claimed that rainwater is as safe, if done properly, good design as always, as municipal water supply. And really, I actually truly believe that rainwater is far safer than groundwater or well water supply, and sometimes safer than even municipal water supply. I truly believe that from what I've seen. And claims about lack of safety are often made by players with a conflict of interest and repeated and shared by sensationalism-driven journalism amplified by social media. It's important to think about water quality in the context of your end use. So, do you currently allow rain to fall on your plants and irrigate your garden? And do you have any concern about the quality of the rain that's falling from the sky? Likely not. So with that, know that it is relatively simple to design a system that produces quality water very sufficient for irrigating your garden. Okay, and I'm going to ask another question, and I'm not sure. I've never used the webinar platform on Zoom. I'd love for you to answer this in the chat if you can, and maybe Christine can read your answers. I don't want to make any incorrect assumptions, but for those of you who are currently providing water for your livestock, how or what is the source of the water you're currently giving to your livestock? So I'm going to guess. Oh, are you going to read out to me, Christine, what people
I was gonna
have?
say I can read out. I haven't gotten any chats here.
Okay,
But
I'll leave it
oh,
there.
somebody said, can you see them?
No, I can't unless I have to look somewhere, but I'm kind of blind.
Okay,
I can
I
just,
got you. I got you.
yeah.
We've got two responses. So somebody says city water in large storage containers. Thanks, Melissa. And then Laura Stern said rural water, dam, and stream.
Yeah. And so the question, I'm gonna talk about best design practices, but if you're here at this presentation today because you're considering using rainwater or thinking about it for your livestock, one question that you need to ask yourself is, what quality of water is acceptable for your livestock? And I can't necessarily answer that question for you. But I do know this. Often, for many farmers or homesteaders, acreage owners, the acceptable level of quality for their animals is quite low. Surprisingly low, maybe lower than I would probably provide myself. So let me give you an example. I know of many systems, I know of many farmers who give their animals water out of dugouts, out of streams, or any surface water or water that has touched the ground. And so the likelihood, if you're getting water to your animals through any of those stormwater, what I would think stormwater sources, the likelihood that it is contaminated because it has touched the ground is much, much, much higher, like a magnitude times higher than water that has come through the sky, right? So just think of that as when you're comparing apples to apples. So just by switching to rainwater for your livestock, it's if you're currently just doing groundwater, just switching to rainwater is likely to provide higher quality water to your animals, period, no matter what you do, just because your source water is cleaner. And I'm gonna show you, I'm gonna give you the steps for what I do to provide water quality sufficient for irrigating my garden. And personally, I wouldn't blink to give that water also to my chickens and ducks. That's what I have here on my acreage. Because I know that that's cleaner than the well water or the creek water that I otherwise have access to for my animals. However, the caveat here is that you may choose or you may want to give your animals the highest possible quality water, i.e., the same quality that I would recommend for human drinking, right? Which is higher quality than irrigating gardens. And so if that's the case, there's an extra step, and I just need to point that out right here, or there's an extra intervention that you should add to your system. And I want you to keep that in mind as I go through the rest of the presentation, right? So the point is, at the end of the day, you might take different steps depending on how high of quality water is acceptable for your situation. Are you only irrigating your garden? Are you satisfied that that's good enough for your animals, or do you want to go like one more intervention and provide water to your animals that you would also feel really comfortable drinking yourself, or giving to your children? And that's okay. There's no right and wrong answers. I'll point out the design, how that impacts your design considerations here as we continue on. Okay, a few more slides on, is rainwater safe? And I have to hit this one really hard, because if I don't, and I just dive straight into how to do it, all the questions end up being around safety. So regarding designing your system, when it comes to the question of water quality, there is a strong misplaced bias towards two things. One is material choices, and one is what I'm calling end-of-line treatment. So let's start with material choices. Material choices are overemphasized in almost all the literature and all the design recommendations you find everywhere online. Materials have a much smaller influence on actual water quality than you think. And it's actually quite simple. Stay away from toxic materials, especially if you plan on anyone or any creature drinking it. And there's probably a question about asphalt shingles or plastic tanks, because in the chat or in the webinar, somebody's thinking about it, because nearly 50% of the questions I routinely get about rainwater harvesting system design is about material choices. But as I just told you, and maybe this is really surprising, your choice of materials has I think it's something like less than 3% impact on water quality. And this is from actual published studies. And comparing even cheap plastic tanks to stainless steel. And if you're scratching your head thinking this doesn't make any sense, I'm gonna explain a little bit more why that is. It's really neat. There is an exception to this, and that I've kind of mentioned already, but I'm going to re-emphasize it because it's so important. Stay away from toxic materials, or sometimes coatings. So lead flashing is kind of common in older homes. And so you don't want anything lead, of course. Sometimes anti-mold coatings used on shingles in wetter coastal areas can be toxic, or some roofing materials. So that's to keep in mind. So this material choices are overemphasized with a giant star caveat: stay away from anything toxic. The other major misplaced bias when it comes to rainwater quality is what I'm calling end-of-line treatment. End-of-line treatment is any sort of a black box that you purchase from some third-party product supplier, manufacturer, to put at the end of your rainwater harvesting system. So some examples, it could be a UV system, maybe you've heard of that, ultraviolet, an ozone system, or some sort of a chemical-based disinfectant such as chlorination. Know that these black boxes, these end-of-line treatments, are they're expensive. They're actually unreliable, and they're often complete energy hogs. Now, I often deal with a lot of clients wanting to build regenerative autonomous homes, right? And they want to do off-grid energy. They want to grow all their own food. They want to do all their own water. But the second you start putting in, you want to do rainwater, but you're going to put some sort of very energy intensive UV system to clean that water, you end up having to double the size of your solar panels because you need that much more energy. And at the end of the day, none of these are actually necessary when good design is in place in the first place. Chemical, metals, physical contamination will not be addressed by UV, ozone, or chlorination. Only filtration, or sometimes called ultrafiltration, will take away chemicals, metals, bacteria, and virus. So that last intervention that I hinted about for drinking water, for high quality drinking water, is some sort of a ceramic uh, filter, sometimes called ultrafiltration, sometimes called filtration. I'll talk more about the specifics of that, but that's what you do to gain confidence that you don't have any, I should say, gain final confidence. You don't rely 100% on one intervention, but that final filter is like your last check. And you do not need any black box for producing really high quality water, even drinking water. And you certainly don't need a black box like UV or ozone or some sort of chemical-based disinfectant for irrigating your garden. The last major point is very simple, but it's paramount, and that good system design is key. You want to work with and enhance the natural treatment train. I'm going to talk more about that and what it is. And so just to kind of get you thinking about that, think about how good a wetland is at cleaning water. You're going to want to work with and enhance the natural tendency that water has to get cleaner over time. So how? That's the big question. Let's dive into some what I'm actually saying. Have you ever seen the Swiss cheese model? And that's what this slide is. This is a model used in risk analysis and risk management. It's used in aviation, engineering, healthcare, and more. In this model, we liken human systems to multiple slices of Swiss cheese, which have randomly placed sized holes in each slice. And these slices are stacked side by side. The risk of a threat up here, hazards, being a reality down here, is mitigated by these different layers or interventions, which are stacked one behind each other, right? And so the lapse and weakness in one layer does not actually allow a risk to materialize down here, since there are other interventions that also exist, i.e. these other slices of cheese. And these multiple interventions prevent a single point of failure. So this model and this thinking applies absolutely to rainwater harvesting system design. And let's talk about how. Actually, we're going to dive into how momentarily here. Because there's often this assumption that there's a contaminant out here in the sky or up here in these clouds. And that there's something up here in these clouds, and that means that down here, way down here, you're going to end up with severe illness, or your animals, or your plants, right? But you'll see that a well-designed and sensibly maintained home or farm scale roof harvested rainwater system includes many of these interventions. There's interventions at the roof, there's interventions at the entry to the tank, there's interventions at the pump. And actually, I'm going to talk a lot about the tank because that's where a majority of the interventions exist. And then as you're kind of thinking about the quality of the end use you might put another intervention at the sink where you're about to drink it or where you're about to maybe take water to give to your animals. And then this diagram I use when I'm teaching how to bring rainwater into the home to use safely. So it also includes interventions, via your hot water system in your home, which aren't applicable to this conversation here. And even to be honest, there's interventions, one count, if what does MID stand for? I'm drawing a blank here. It stands for minimum infectious dose. So there's interventions in our mouth and in our gut as well that if some small thing made it through all these pieces of sliced cheese, depending on how healthy or unhealthy you are, we have one count of anything doesn't make you sick. Typically, it's numerous counts. It's numerous counts of something over long periods of time that'll make you sick as well. So that's another thing to consider. let me just pause here to think quickly about if I'm missing any other point I wanted to make on this slide. But this Swiss cheese model is the thing that's really important. And that things up in the cloud that you might hear or in the sky do not mean that they're at this point where you're taking water out of your rainwater harvesting system. You've got all these little design things that we are going to do to make sure that we feel very confident that the water is the water quality matches its intended end use, whether that's just using it on our garden or potentially feeding it to animals, or even, potentially drinking it ourselves. All right, this slide. So my question for you, I just showed you the Swiss cheese model with all these interventions and talked about a rainwater harvesting system. Again, Christine, I think I'm going to need your help here because I want to ask anybody who's watching if they think this is a rainwater harvesting system and if they see any interventions in here.
We've got crickets, Michelle.
That's okay. I'll just keep going. So, and the answer is no.
Somebody said
Oh, yeah.
you.
Mm-hmm.
Oh, here they come. Somebody said you need to screen out the leaves. Laura suggested that. Melissa suggested collects rainwater but has no
Yeah.
intervention.
I would
And
consider
then
that. I wouldn't consider this a rainwater harvesting system. I completely agree. Yeah. Sorry, what was the last one?
we got two more. Robin said the top could be filtered, and then Patrick said nothing beyond a sediment basin.
Yeah, exactly. I do not think of this as a rainwater harvesting system. And this could be one big difference between, you'll find stuff on the internet where people will say rainwater will make you sick. And I agree. If this is your rainwater harvesting system, you will be sick. But this is not my definition of a rainwater harvesting system, right? And so let's clear that up before somebody, there'll be some YouTube comment here in like 3 years from now where somebody's going to say, Michelle's going to make you sick, right? Because this is what they're thinking rainwater is, capturing and storing and using rainwater is. And I say, this is not what I'm talking about. You will get poor quality water out of this, even for watering your plants. I don't think I'd want to water my garden out of this like open barrel here. So why don't I show you a system? What do I mean? Let's follow a drop of water through what I consider to be a good rainwater harvesting system, starting with the roof surface, which is number one. So let's see how much you were paying attention. And you can answer just silently, or you can yell it at the screen. But how much does the roof material up here, this guy right here, how much does the roof material impact the water quality coming out down here, downstream of the pump? And I'm going to assume that everyone says very little, right? So unless you're using something toxic, lead flashing, roof coatings, roof materials themselves actually have a relatively minor impact on overall water quality. Having said all that, if you're planning on bringing water into your home for drinking, and I know this is for livestock and gardens, but I have to say this, such as what I do here at my home, I would still choose the highest quality material. Not to say it's not to say go out and choose crappy materials. There is some impact, and when it comes to drinking water, I still want to make sure myself and my children have the cleanest water possible. So for instance, I do have a metal roof, right? That's important to me. But unless you're planning on drinking it, I'm not that fussy. And if you're planning on drinking it, I'm just a little fussy. Especially as long as you follow all the other design practices. Okay, next is the gutter, or in Canada we call them eaves troughs. Eaves troughs? I don't think you call them that in the US, gutters. And what does the gutter do? Again, I'm going to pause for you to answer out loud, but I'll just kind of keep forging ahead, pretending like I can hear you. Your gutters collect the rain and divert it to where you want it to go. And also, don't forget that gutters are really important to direct it away from where you don't want to go. So are gutters unique to rainwater harvesting? So And what I mean by that is if you have no intention of capturing rain in a tank or using it, do you still want gutters on your roof? And like, absolutely, yes. And why? It's because that's how you protect your foundation, and it's just good building practices. So I don't want to go a ton into gutter design. You need gutters for all your buildings. It's terrible if you don't have them, but they become even more important when you're thinking about harvesting rain. What about gutter maintenance? Is gutter maintenance unique to rainwater capture and storage? Absolutely not, right? So there are some good design practices for gutter design and maintenance, but none of these unique to rainwater harvesting. Poor design can wreck your house. It can lead to corrosion if you don't clean them out. You'll I think the biggest thing for rainwater actually is if you don't take care of your gutters, you're missing out on water that you could have harvested, right? If water's pouring out of your gutters and not making it into your tank, it reduces the efficiency of the amount of water you can capture. But it's actually not a water quality concern. Um, let's keep following that drop of water. The next thing you'll see on the drawing here that I don't even have a number on it because I don't think it's relevant to you folks not in cold climates. This is called a diverter, and it's really just used in cold climates and sometimes other times. There could be other considerations. If you want to at times direct the water in one direction, like we do in the winter, and at other times direct the water into the tank. So that's all that is. The most important, I'd say, maybe arguably the second most important element in your rainwater system is this guy right here called a leaf diverter. And sometimes it has slightly different names. You can see the image of it. It's really a screen that prevents excess nutrient. Nutrients are leaves and dirt from entering your tank. It's really, really important.
Sorry, everyone. It looks like Michelle might be having just a little bit of a connection issue. Let's see if she can come back on here in a minute. In the meantime, if anybody has a question for Michelle, and you want to post it in the chat, or maybe we could just start typing out those questions and collecting them and organizing them. Hi, Michelle, welcome
Oh
back.
my God, what's happening? Why the internet's not liking me today. Sorry about that, guys. I'm back, and I think
It's
I
always
noticed right
technology's
away.
fault. Yeah,
Yeah.
it's not you, it's technology. So we
Yeah.
forgive you. And I'm sorry, I don't remember what the last thing you said
I
was.
think I do. I'm pretty sure I was talking about screened inlets and outlets on your tank when suddenly
Oh,
it
yes.
went blank.
Yes, that
Yeah.
sounds familiar.
Okay, so give me a second here. I got to get back into my presentation. Uh, presenter view. Hopefully you were able to entertain everyone, maybe with some rain jokes or something. Uh, okay.
I did a shameless plug for some questions that they may have
Okay.
for you. Nothing's pouring in yet, but I think they're pondering. So I kind of gave them
Okay.
homework
Okay.
over entertainment.
Great. Bear with me here. Again, I got to reshare everything and get this. Is this the same one I was sharing before? Yeah,
I,
you
I
can
believe
see
so.
all the tabs I had to open to try and find you guys again. There we go. Okay, I got a thumbs up. So that's good. That sounds like you guys can see me. All right, I believe I was in mid-sentence around screened inlets and outlets on your tank, saying that in addition to the leaf diverter, it is it is absolutely crucial that you have screened inlets and outlets on your tank. So that's what I have shown as number 3 on the diagram. Um, the fourth the fourth intervention shown on this illustration, which is actually a whole bunch of stacked interventions, is your tank. And I'm going to spend several slides talking about tank design and how water significantly increases in quality even after a short amount of time hanging out in your tank. And it's like several of those layers of Swiss cheese. And I love this stuff. It's really fun. But your tank is a bioreactor when designed properly. Cliffhanger for a moment from now. For irrigating your garden, you'll likely need a pump, and probably, to be honest, even if you plan on, using this water that's been in your tank to fill up something for livestock, you'll also need a pump. And the pump is another one of those Swiss cheese layers. Any guesses as to why a pump would improve water quality? I'm going to wait. I like it when people have to think a little bit. I think it kind of fires the neurons a little bit. So any guesses, just throw them up and we'll wait a minute before I give you the answer. Why would a pump improve your water quality? Oh, you know what? I think I can see the chat. Yeah. Process
Oh,
moves water around. It just
yeah,
popped up.
Melissa's. Hey,
Yeah.
welcome. This webinar feature is fancy. It takes a bit to
Yeah.
get used to. Yeah.
Okay, so the answer is there's two parts to it. So pumps, when they're designed by mechanical engineers, they you can't put anything really but water through a pump. The second you have anything like any kind of material, solid material going through the pump, you will break the pump. So pumps like should always come with an inlet filter. And those inlet filters are almost always 30 micron filters to protect the pump against mechanical failure. And the average human hair is 150 microns. So already the pump has a filter on the inlet side that's like a fifth of the diameter of a human hair to try and take out any solids that might be in your water. So there's another filter that's going to actually, prevent anything that might not be water going through there. And then the second thing is that pathogens are actually quite fragile and they hate sudden changes in pressure. So the pump itself, the change in pressure, is it kills bacteria, kills pathogens. So that's another layer in the Swiss cheese. So if anything doesn't get hit by the previous interventions, and I haven't even talked about all the interventions in the tank, the pump is another one of those Swiss cheese layers that little bad pathogen has to get through. Then number 6, I show. Unfortunately, I put it on 6, but I didn't show it on the diagram because, of course, I just used a diagram more so for using rainwater in a home. But of course, it's quite similar. You just downstream of this pump, you wouldn't have this dual water supply. Maybe you would. This guy here is a switching valve that can switch between municipal water and rainwater. It's a really nifty device. So you may have this, you may not, depending on your system setup. But just downstream of here, you would have a number 6 if you wanted to drink that water yourself or you wanted to provide the highest quality water for your animals. I would say if you're just irrigating your garden, I would stop after number 5. I wouldn't bother doing the last number 6. That's why I said it's optional. And that would be a final filter, ceramic with carbon. There's lots of great reputable brands. It's the same kind of filter that I would use under your sink. The same kind of filter I actually recommend that people put on their municipal water supply, usually a 1 to 5 micron filter. I think everybody should have a filter at the tap that they're drinking water from. And I don't care if you're getting your water from the city or from groundwater or from rainwater. It's good practice. But the reason maybe not to do it for irrigating your garden and maybe not to do it for irrigating your livestock is if you, for sure for your garden, you don't need that quality of water and it's going to cost you more in energy costs because the minute you start trying to pump water through a filter, I don't know if any of you have ever been camping with those like ceramic filters when you try and clean stream water, right? It takes quite a bit of energy, pumping energy, to push water through these very small micron filters. So that's the thing you have to consider. It's going to cost you more in energy to push water to get it higher quality. Next one. Okay, let's just give you a little bit more detail on those things because I flew through them really fast. Here's a closer picture of the leaf diverter. Simple two-screen design with a 45-degree angle here and a horizontal finer mesh screen here. It's extremely effective, although extremely simple. And if you can manage your downspout configuration, it's best to only have one located just upstream of the tank entrance, as opposed to trying to have like multiple leaf diverters at multiple locations. That's pretty much all I have to say there. You can get, you can get all sorts of versions of these and really fancy ones and really expensive ones. But Peter Coombs, my colleague, has actually done research trials on all the different versions, and they found the cheapest, simplest version of this leaf diverter worked best, actually had the best results. I'll say, they're manufactured in Australia. They could be a little bit hard to get in North America, but I have students who have definitely gotten their hands on them. And here's just a quick photo showing you there's the diversion valve that at my previous home when I lived in the city, and we would switch it to go down this way in the wintertime. What I like about this image is you can really see the asphalt sediment coming off the roof. It was a relatively new asphalt roof that we put in, and see how effective this screen is at basically not letting that debris get into my tank. I mentioned the importance of screen inlets and outlets on your tank. So the key thing here, and think back to that picture I showed you about the open tank. A well-designed, a real rainwater harvesting system is a low nutrient environment. What does that mean? That means that there should be very little carbon, nitrogen, phosphorus. That means no leaves, no mosquitoes, no gunk. There really nothing should be going into your tank other than water. And you can achieve that with screens. If you have an open air tank, you will end up with a high nutrient environment, and also maybe like a dead mouse or a hatching mosquito colony. If you add stormwater to your tank, so that means if you then you have a roof harvested system, but then you capture some water from a swale or from some landscape feature, you will also end up with high nutrient in your tank. And groundwater is also sometimes high nutrient, right? So just something to think about if you're mixing rainwater and groundwater. There is a claim out there that your tank walls must be opaque and not let light in to prevent algae blooms. And this is a complete myth. Algae blooms are the result of eutrophication, which is due to high nutrient loads in a water body. All right, so I've just said this, but I'm going to ask you back. Is a rainwater tank, a rainwater system, a high nutrient load system? No. So there should absolutely, like if you have algae blooms in your rainwater harvesting system, you do not have a rainwater harvesting system. You have some open trough, some tank. So you do not, so light levels actually don't impact the quality of your water. So if you can get a clear tank, and that's the cheapest one you can get, and like those 1,000-liter totes, IBC totes, I quite like to use those. They're cheap and often easily accessible, as long as there's not something toxic that was in it before. Those are good options. So yeah, screened inlets. There's one more. You can see there's a screened inlet here on the inlet, but don't forget your overflow should have a screened on it too, because normally water should only flow this way. But if your tank level is low, you could have a mosquito or something, come up through this overflow and get into your water. The next thing you want to do is let the tank do its magic. So your tank is a bioreactor. What does that mean? Why does it get me so excited? So there are key processes happening in your tank that greatly improve your water quality. Never mind the fact that roof harvested rain is relatively high quality to begin with. It gets into your tank. Um, the key processes that are going to help make it even better water quality are settlement, flocculation, bioreaction, competitive exclusion, biofilms. Okay, what did all those things mean? You don't need to memorize them. Let me simply help you understand the principles and how these influence your tank design. So when a drop of water enters the tank and first hits the water surface here, it first hits this water surface microlayer. And in the unlikely event that harmful bacteria have gotten into the tank in the first place, they will be trapped at this water surface layer right here. So there's another intervention, another Swiss cheese. Next, the water column itself under the surface layer is slowly moving due to slight temperature variations. So the water doesn't, I mean, it actually does kind of move. The processes of flocculation and sedimentation continue to clean the water. So flocculation is when suspended solids clump together just naturally and form what is called a flock, larger chunks that kind like they're small little chunks, so they're suspended and then they start kind of touching and then they form a bigger chunk and then they just settle to the bottom. So you're gonna get a lot of settling. And then we also have biofilms. And biofilms is this bacterial film. It's a mixture of different microorganisms that are held together and protected by glue-like materials. They form they form in rain tanks and they form everywhere. You have biofilms on your skin. I have biofilms on my computer and on my desk. We're surrounded by microorganisms, right? They form at the tank walls and in this bottom, the sludge layer is also a biofilm. And quick question for you. I'm going to keep hitting some of these same things home over and over again. Is your rainwater tank a high or low nutrient environment? And hopefully you're screaming at your computer, low nutrient, right? Okay, so in a low nutrient environment, the biofilms in the sludge get very hungry and they are extremely effective at the removal of dissolved organics and inorganics. So basically, what am I saying? These biofilms, they strip out organic and inorganic materials to feed themselves. And so what is an organic? What is an example of an inorganic material? Lead. Perfect example. They are, in fact, so effective in the removal of bacteria and metals that labs and research have measured that there's lead in this biofilm layer more than like 12,000 times the lead in the water column here. And that there's lead in the sludge like 50,000 times higher concentrations than in the column. Bacteria is like 1,500 times more potent or more concentrated, is a better word, in these biofilms. And E. coli is like 1,000 times more concentrated in the sludge than the water column. And so the reason for some very misleading studies on the quality of rainwater, and I'm not joking about this, is that there have been instances where some scientist or some lab tech comes along, wants to test the water in the tank, and stirs the tank, gives it a good stir, and then tests the water in the tank and says, "Oh, this water is terrible," right? And so I often get asked how quickly the sludge and biofilms build up. Know that biofilms develop within hours. They're very quick and they're well functioning within 24 hours of starting the operation of your tank. And oops, I didn't mean to change that. How fast do they build up? So how, like, are you going to end up with like 3-inch thick layers of biofilms on the floor and like a foot of sludge at the bottom? No, you're not. The rates that they build up vary. In a really dusty location, if in a really dusty location, you might get like 1/3 of an inch per year, but 1/10 of an inch per year would be more typical. And they don't just keep building up; they kind of eat themselves, similar to your septic tank. That just it's a living kind of an organism. Oh, it's a biofilm. It just kind of consumes and eats itself and tends to just gets into a stasis. So to summarize this very exciting slide that I like very much is that naturally occurring biofilms in your tank are very important for the removal of bacteria and metals in the water column. The microflora in rainwater tanks is consistent with natural ecologies, i.e., these biofilms are not unique to rainwater harvesting, and the biofilms should not be disturbed. Let them do their job. Okay, I know we're getting to the top of the hour. I can get through these best design practices in the next, I'm pretty sure I can get through these before 2, and then I'll open it up to questions if you're wondering where we're going. What does all this mean? Okay, so here's where I will actually share a copy of this presentation with Christine if she wants to pass it around, but these are the notes I would take. Let's make some design decisions. So let's make some design decisions based on what I've presented here, what I've talked about. 1, draw water from 4 to 6 inches from the bottom of your tank and avoid disturbing the sludge layer. So that's what's shown here with number 1. Very important. 2, you must have an overflow, and that's less about water quality and more about, good design. You don't want the water flowing out the top of your tank. So there's number 2. Use an overflow. And then it's good design practice. Use that water productively. Like that's still great water. Send it to a swale that's going out to your orchard or something. 3, your tank must be able to breathe and vent. These biofilms, like they're aerobic biofilms. So those waterbed, or they call them bladder tanks, I really don't like them. They don't produce good water quality, and that's why they don't have biofilms. Or they don't have aerobic biofilms, I should say. 4, place the tank inlet close to the center of the tank, or alternatively, place the inlet and outlet on opposite sides. And that's just to give the water a little bit more time to move through the tank and to stay in the tank. 5, I suggest a minimum 1 minimum. It's hard to get smaller than minimum 1 millimeter mesh. So 1 millimeter, I should drop that word, minimum. 1 millimeter mesh screens on all inlets and outlets. And when you're looking for screens, think about the screens that keep mosquitoes out of your house. That's what you're looking for. 6 is your optional. 6 is your final filtration if you're wanting to get the highest quality water for drinking or the highest quality water for your livestock. And this is I said this already, it's like a ceramic. Look for a ceramic plus carbon filter. There's many reputable brands. That's the most important thing. If you go for the 1 micron is going to give you the highest quality water. 5 micron, possibly a little bit less high quality. And 1 micron is going to need a bigger pump, more pumping needs, more energy use than the 5 micron. But that's a range that I would feel comfortable for sure. And I'll say again, I don't have, for my livestock, I would probably just stop at number 5 if I was just doing garden. Number 5, I feel like the pump is missing. Yeah, 5 minimum 1 millimeter mesh screen on all inlet and outlets. On the previous drawing, you have a pump. You have to push the water somewhere, right? You can't typically. You need to put the pump to irrigate your garden, so it's there. Know that the pump is another iteration, I suppose, would be 5.5. 6 is your optional final filter. 7 and 8 are just, more like mechanical design practices or structural design practices. Yeah, water is heavy. I see people underestimate their foundation all the time. And if your tank starts settling, you'll have issues. So make sure you have a solid foundation. And 8, leave it alone. Don't disturb. And this is about not disturbing that biofilm. You probably don't need all these fancy things, which kind of make it intimidating and confusing to do rainwater. First flush, fancy filtration device, quiet inlet, floating intake, 45-degree beveled outlet on overflow, or any other fancy devices. Oh, there's a review slide. That's exactly what I just said. If you do all these things, you will have water quality sufficient for irrigation. And up to number 5. Number 6, consider it for your own personal consumption and possibly for your livestock, depending on the quality you want for them. Remember that you're starting with rainwater, which is already very high water quality, plus all these natural interventions in your design. Okay, I think I'm going to fly. I had some stuff on material options. Metal tanks. Oh, well, I want to leave time for questions, so I'm going to skip over these. This is the pros and cons of different tank styles. But even these slides, the message is the material has less impact on water quality than you might think. Often your choice of tank size and tank material has more to do with budgets and space constraints. I really like poly and plastic tanks. I think you can't beat them for price and water quality. These are our tanks, our water tanks for our livestock. This is one of those totes that I mentioned, which is not a bad option. They're often really cheap to get your hands on, but make sure there wasn't some sort of gross chemical in them before you use them. There's some nice slimline tanks, fiberglass tanks, awesome option. Gutter design, I talked about this already, so I'll just show you some pictures because we're getting short on time, and I want to leave room for questions. Okay, I'm tempted to pause here because we have two options, Christine. I have kind of like the 5 most common questions that people ask me about rainwater, and I could hit those, or we could stop here and I could just see if there's questions from the audience. So
So I
I
have
think there's
talked to it a few times. So maybe we'll just dive into those and then.
okay. And I'll suggest that if you do have a burning question, now would be a great time to think about it and put it into the chat because I'll try and pay attention to both. So before I dive into the most common questions, um, I should say the most common questions I receive are almost always concerns about rainwater quality. Like, is it safe? That's why I started a whole 20 minutes just trying to, talk about why rainwater is safe. So a reminder, there is a quality and health paradox. Over 3 million Australians rely on rainwater without a black box, without UV or chlorine or anything like that, and for drinking water. And studies have shown that these rainwater users have similar or even better health outcomes to people drinking water supplied by their municipality. Claims about safety are often made by players with a conflict of interest, and lots of, the age we live in. It's really easy to share things. What about airborne pollutants, such as herbicide, pesticide spraying, and pollution from industrial areas? What about pollen? What about ash? So I want you to think back to the Swiss cheese risk model, and something might be in the clouds, right? Or it's in the clouds. Does that mean that it'll be a problem at that end point where you or your animals or the water you're irrigating your gardens? Will it be there? So the good news is that many chemicals are quite fragile, perhaps with the exception of DDT. But the good news is that nobody should be aerial spraying when it's raining. I hope not. Um, Trace levels of pollutants can be found in studies in the biofilms and in the sludge, but they're not found at the tap. We do need to be mindful and not dismiss that there could be a problem, but let's not assume that because it could be, it is. And that's what I see a lot of. Somebody says, "Oh my God, there's something in the sky. Don't drink the rainwater." And we're not talking about just like opening your mouth and drinking stuff from the sky. We are going through some interventions, as unobvious as those interventions may seem. Should people be crop dusting over houses? No, they should absolutely not be, especially if you have a rainwater harvesting system. And the natural treatment train, like the interventions in the tank, those biofilms have been shown to address pollutants in the air. So that's really great news. What about cows, birds, reptiles, pooping on my roof? Well, the good news is there is such a large difference between what would be a pathogen for a squirrel and what could be a pathogen in a human. The real question we need to ask, does feces or poop on the roof transfer a harmful bacteria to the point of supply to a human using that system? And there's not been a case of this happening in a well-designed rainwater harvesting system. Peter once told me about a case in Australia where a woman got quite sick, and it turned out she had a possum like that had died in her rainwater tank. But obviously, if the possum got in, there was some serious issues with like screens and like not taking good care of her rainwater harvesting system. Um, Clean and sterilize my tank, right? Shouldn't I do that? There's actually lots of information out there that once a year you should empty your tank and sterilize it. Absolutely not. Leave your tank alone. Um, these recommendations often come from the idea that, hey, we put chlorine in our municipal water supply, so we should also put chlorine in our rainwater harvesting storages. Mixing chlorine with organics is a real no-no. Chlorine is a powerful and deadly chemical, and I would never recommend that anybody use it. How long can I store rainwater is another one I hear a lot. And so my question to you is, why would it rot? You know, how could it go stagnant or grow algae? Um, so maybe surprisingly, but the truth is, research has shown that water quality actually goes up over time and not down. So time actually is your friend. What if I don't clean my gutters? Um, Actually, the truth is, very few people do clean their gutters. And Peter and his research team actually did a study to understand its impact on water quality. And ironically, they discovered that even though you should clean your gutters because it'll wreck your gutters, it'll cause corrosion issues, and it'll reduce the amount of water that you can harvest, um, it actually delivers better water quality if you have leaf debris in your gutters. And that sent them through, that was quite a surprising result. And then they discovered that it's because you end up getting biofilms in your gutters too that further clean the water. So if you're not really good at cleaning your gutters like I am, and you can rest assured that's actually a benefit to your water quality, not a downfall, but you should still clean your gutters. What about acid rain? Um, Here, rain is actually a natural carbonate. So that means it has a pH of 5.5. It's not neutral, it's not 7, it's 5.5. But there's nothing to see here because this lower pH is simply due to its chemical structure and not pollution. Acid rain, which has a low pH because of sulfate pollution, right? So when we say acid rain, what we're really talking about is uh, sulfate pollution. And the good news is that since the 1990s, when US and Canada made some major changes in what's in our motor vehicle fuels and imposed a bunch of rules, this issue has been substantially reduced, the sulfate pollution. So rain is low pH, but not low pH because of sulfate pollution. And so you'll see recommendations out there to adjust the pH of your rainwater and attempt to get it to a pH of 7. This is completely unnecessary. This recommendation comes from the water utility paradigm. They require a pH of 7 because they are trying to control corrosion and because some of the chemicals they use in their water supply network work better with a neutral pH. So again, this is a really good example of a design practice that has been completely illogically applied to rainwater harvesting systems, where they say balance your pH, put a concrete block in your water. Um,
Michelle,
I
we
think
do
this.
have a few
Yeah.
questions
Oh,
here.
good. Thank you for stopping. I think I could stop here.
It's just I could
Absolutely.
listen to you for so long. You're so interesting. Um,
I just go in blah.
I like it though. You're
Oh,
not like filler words. You're actually giving information, so that's so great.
oh,
Melissa
yeah,
asked a question, and she
yeah.
goes, "How do we store water for
Oh,
livestock during the
yeah.
winter?"
I mean, so um, okay, so it's that's a great question. I don't necessarily have an answer for you other than like how do you what you're asking is how do you prevent water in a tank from freezing, right? And we have those considerations in northern climates. And the solutions, the possible solutions to you are um, the same you could have additional heat. So you could have heat tape. Where you're going to freeze is at those inlet and the outlet, the smaller diameter. That's where you're going to get freezing issues. So you need to provide some sort of like heat. Or what's very commonly done, because that's expensive and that's an ongoing cost, is we bury
Michelle? Oh no, we've lost Michelle again. Um, let's give her just a second to get back to all of her links. But here, Laura, we haven't forgotten about you in the chat. We'll kind of get next to your, we'll get you next in the line when she comes back on. But Michelle is just, she's blowing my mind right now. All the information she's sharing. I'm really glad that we're having her speak on this topic. Hi, Michelle. Sorry.
Thanks for your patience, guys. I just disappear for a sec so you guys can all just kind of like get a few minutes of quiet to ponder what I've said,
Just
right?
process, right? Yeah. So I think you were talking about burying.
Yeah, so it's really common, in our climate, and we have the same issue with septic system design, right? You have a septic tank, and we can't let that freeze either. So we bury them below the frost line. So you can do the same thing with if you're trying to store water. It's more expensive up front to, dig a hole, and it's a little slightly more expensive tank. But then once it's in, there's no ongoing cost to keep it from freezing. Another
Hey, we
another
love to
thing,
hear that.
yeah, another thing I've seen, and this is less for livestock and gardens and more for like homestead design, is actually integrating the tank into the basement or into the house, right? Because you're already heating the house. So you have to get creative. I know people who have a greenhouse who have the tank in the greenhouse as well. Another way, because they're already heating that building. So, the answer to that question would be really context specific, but you're probably going to be thinking of like, what's your budget? Are you willing to put in a little bit more upfront cost to save yourself on long-term operating power? And I would definitely encourage you to do that if you can, because who knows what energy we know what the energy costs are right now, but who really knows what it's going to cost us to keep things from freezing using electricity or whatever source you have. So I do have in the longer course I teach, and in that free YouTube course too, I talk far more at length in terms of on how to design and install underground tanks. So I'll give you that to kind of get you thinking
Yeah, we
about
do
that.
have that shared in the chat. And then for those following along on the live stream, that should be in the comment section below. If you're having issues with those links, just comment or let us know. But we also do have most of our Michelle's information and the website, all those information links that you can get. And really, you should check them out because our other webinars don't always come with these great resources. So a whole course, let alone. But thank you for sharing that, Michelle. And then we did have a few questions from Laura. She goes, is there a rule of thumb for the ratio of the area of roof where the water is collected to the garden area that can be irrigated?
No, because it's so dependent um, on your climate, right? But there is a really quick calculation you can do to figure out. Actually, okay, I'm going to give you a couple of rules of thumb and tell you a quick calculation you can do. So, my rule of thumb, and this is like super rough, but when people are just kind of curious about doing rainwater harvesting and don't want to put a lot of effort into thinking about what size tank they should get, just maybe want to do it for garden irrigation, I actually just recommend yeah, I'm going to say 5,000 liters, which I think is like 1,300 gallons, US gallons tank. It's quite a bit bigger than you might think. Like those tiny little rain barrels you can get from your garden supply store, that's just not going to cut it. It's too small. But if you're like thinking about getting a little bit more serious, I would definitely recommend like 1,000-gallon tank to get started. And then just make sure you have extra ports on it so that if you wanted to put a second tank, you can, right? Start small and build yourself a scalable system. Especially with garden irrigation, we often don't really have a sense of how much water we're using, right? So even when people say, "Help me design a garden irrigation system," I say, "Well, how much water are you going to use?" And they're like, I don't know. I have no idea how much water I use." Um, so you can calculate how much water you can capture. And I'm tempted to throw that calculation. It's really simple. You basically look You could probably Google it, just like rainwater capture calculation. You take the area, the projected area of your roof, times the annual average rainfall for your region. You multiply those together, and then there's a factor that you have to use. I don't know it by heart because in US customary units, you have to convert gallons and meters per year or and foot to for the units to work out. When I stop talking here, I'll find the equation. I'll post it in the chat. So it's a really easy way to calculate theoretically the max amount of water you could harvest from a given roof size for the average annual rain. It's very rough, but at least it would start to give you an idea. Like, are you in, like, how big of a deficit are you in, and how many would you have to connect 3 roofs to get anywhere near the amount of water you need? Oh, look at that. You have a little link. Water cache, rainwater collection calculator. Yeah, so there's lots of online resources. I'll say they're very rough because now you're annualizing your rainfall over the course of a year. And the reality is we don't experience rain on an annualized basis. We experience rain like in an instantaneous basis. And so like um in the spring months, if all your rain comes in October, November, December, January, and then you need rain in the spring, that calculation is not there that useful to you, right? So I throw that out there as sometimes helpful, often not sufficient. But the real design advice is start with a scalable system. Put in a medium to largest tank with an extra port so you can add another tank down the road.
That's such a smart idea because usually when you're like, oh, I just need a system, you don't think about future all the time. Well,
Mhm.
some of us are very good about thinking about the future, but
Mhm.
that's very smart and scalable. It just makes sense. So Laura did have another post here. So she had a project where she was collecting rainwater in IBC totes. On one side of the building, the water spread across 3 totes, and the water was only a few inches deep and had the algae lick to it after a few days. On the other side of the building, the water was only collected in 1 tote. That tote had a couple feet of water and did not have the algae problem. Did this have to do with the larger amount of water in the one tank compared to the water being lower in the other 3 tanks?
No, it just have to do with, you know, I mean, algae. It could have just been the biofilms that you could see in the tank. It's hard for me to say. If it was algae, that means you had a high nutrient environment. You had something in that tank. Leaves got in, dirt, carbon got in, something got in that shouldn't have been there. I'll tell you, there's a something fascinating is that if you take water out of your tank from the supply point, right, from where you're planning on using it. So if normally you have a pump on the end of your tank, it's one of your interventions. Test the water downstream of the pump. Put that water in a glass, okay? And then look at the water in the glass. And our eyes, our nose, and our mouths are often like the best, better than lab tests in terms of water quality. And if the water is clear and it has no smell and you can't see anything in it, you can have like and you know that the water going into that tank was from a roof, right? You can have a fairly high confidence that that water is good quality. But if you can see it's miscolored, or if the water smells, or if you can see sediment in the water, then that's an indication that something's not right in your rainwater harvesting system. And it's probably one of those interventions that I talked about. So I would go through them all. You have screens. Are you keeping things out? You know, and then if you do have an issue, that's when you would probably like drain your tank and start over. Right? Fix the issue, drain your tank and start over.
And I'm just a person who likes to push boundaries. So at what point should a person be concerned to where I should probably dump this tank? When they start seeing, algae-like things, maybe when they have floaters, when they smell something.
Yeah, I'd say it's that test I just told you about. Is
Yeah.
it clear? Does it smell? Can you see anything? Right? And clean water will be clear, it won't smell, and you won't be able to see anything in the water at the tap.
And the
And let
main
me
the
tell you
main
this.
thing.
Yeah. Another thing is that like mm, you know what is often the culprit for poor quality water? Tap fixtures. So, do you guys have Home Depot or Rona or like those supply places, and you can just buy those low quality faucets for outdoor irrigation?
Mhm.
So what's really insane is often they're the culprit for the poor water quality. It's not the rainwater. It's your fittings, it's your copper plumbing in your house that's the culprit. And it doesn't matter if it's rainwater going into that or if it's groundwater going into that or if it's municipal water, you're going to have crap water because uh, bad quality fittings, especially some of the metal ones, can sometimes have lead in them, right? So be a
Mhm.
little cautious and then question, like, is this an issue because of my rainwater or is this an issue because of something that would like fittings and plumbing?
A little extra
We tend
research.
to
Yeah,
blame
wow. Well,
rainwater. We tend to say, oh, it's the
yeah.
rainwater's fault. And time again, I've actually discovered that it's not.
I love that there's just stacking evidence against how it's not rainwater's fault. And we need to support rainwater more and harvest it to have better quality drinking water.
Totally, for
Because
better health outcomes, for better sustainability outcomes, for better resilience outcomes, for better security outcomes. I think rainwater is a very underutilized and underappreciated resource.
absolutely, I would agree with you 100%. And
Mhm.
like there's this myth that like even I thought about it until last year, but like collecting rainwater is illegal, in some places people feel that. And so
I know, and that's
yeah,
a tricky one that it's difficult for me to talk about given the legislation. I will say this, I've heard we've had students come through our course in Colorado, I think is one of the states. Um, I've heard Peter can speak more eloquently to this because he's actually involved a lot in court battles now over water. He's at the point in his career where, he just goes to court and is an expert witness a lot on rainwater cases. And he's told me that what's really interesting about the Colorado case is that a lot of times these bans on rainwater have to do with municipalities trying to protect the watershed and thinking that a ban on rainwater is like the ultimate legislation is saying they have to protect the watershed. So sometimes, um, in some sort of misinformed way, they ban rainwater. But it's actually the opposite is true, is if more people stored more water on their properties and held that water for longer, it's actually better for the watershed as a whole. And it's so so I've heard of cases where rainwater was banned, where people have fought back and said like the actual legislation is about protecting the watershed. This ban on rainwater is not actually achieving that, right? And won. So, I tell that story because that's often the case. Like the reason rainwater is banned is a complete misunderstanding of why it should be banned. And
that is
I have a
intriguing.
whole nother presentation where I talk about the benefits, the watershed benefits to rainwater harvesting. But we
Well,
didn't
and
have to
honestly,
do
maybe
that
we'll
today.
have you back on the show because I think that could be a really good continuation for the education that we're talking about and the quality that we want to share with our viewers. So if we have
Mhm.
interest in that, we'll connect and work with you there. But I don't want to take up too much more of your time. I'm really excited for how the chat has gone. Patrick says, yeah, like tomorrow.
Yeah, I'm so sorry. I just took up the whole time and just kind
Do
of barked
not
out everything I
apologize.
know.
We are
But
thankful. We are so thankful
yeah,
to have this knowledge and to get to pick your brain and just connect with you on this topic. A lot of people, we don't have this resource and we have these questions and these fears and these anxieties. And so just to have that kind of authority to calm us down and help steer us in the right direction. I can't
I
thank you
know.
enough for
And the internet is a blessing and a curse, right? Like it
yeah.
is a total blessing and a curse. And so let me assure you guys that trust your intuition on this. And then if you really think about it, it is like it's distilled water coming from the sky. It's so clean compared to like a lot of the other options we have for providing water. And it's kind of crazy what an emphasis there is on how dangerous it is, given just that intuitive thing you can think about. Like, actually, is there a possibility for cleanest water? And so I'll say this. I would actually rather, if I'm going to harvest rainwater, I want to drink it for myself and my family because it's the cleanest water that I personally have access to. That I know for a fact. And I'm gonna give my animals my creek water and maybe not creek. My creek is relatively clean. There would be a reason for me not to give my animals creek water, but our creeks are spring fed, so then the animals will get that. And my gardens are gonna get right now because I can't harvest enough rainwater for indoor uses and outdoor uses. My gardens get my well water. And so I match my water quality to my end use, and my family gets the rainwater. That's because I believe it's the best water available to us, period, bar none.
Wow. Yeah. I mean, what more of a testimonial do you need?
Mhm.
Like I am so thankful for you sharing your knowledge and letting us know, the myths and the fears that we really shouldn't focus too much on. So again, if anybody wants to connect with Michelle here, we've got her contact below. But again, I want to thank you for joining us today. We do appreciate your time. And so if anybody else would like to follow along or subscribe to our YouTube to be notified of our next live stream, go ahead and do that now. This segment has been funded under a conservation collaboration cooperative agreement with the Natural Resources Conservation Service. I always switch out between NRCS and saying it out loud. And the South Dakota Specialty Producers Association to promote sustainable agricultural practices and environmental stewardship. Its contents are solely the responsibility of the authors and do not necessarily represent the official views of the USDA or the NRCS. Again, I'm Christine Reiner, and to learn about what upcoming events we have or reach out to more people and experts like Michelle, follow our Facebook, and our website has so many different resources for upcoming events. But please let us know if you have any questions. And I want to thank you all for listening and asking Michelle these great, amazing questions that are very specific to your experiences, which I think people may learn from the best of just like real life, real time. So I thank you all for taking the time to just educate yourself on a topic maybe you didn't have all the knowledge on today. So thank you again, Michelle.
Okay,